Hello CS50, I'm Yongsing from Malaysia. This video will bring to you through CS50 Final Project concepts and some code running at the end of the video. So as title mentioned, predictive maintenance. So this project will be using machine learning to help in predicting machine failure. So this project initiative is to develop a model that used in real life application in industry. Also as a training ground for me, myself to examine my understanding of machine learning, and finally as a part of my portfolio project. So this project will be get an input from an open source dataset from Kage platform. So here is the look of a dataset. After getting the input, the code will be performed data cleaning to handle some missing value, null value, and remove some unwanted information. Then it will come to machine learning function that is trend test split. This function split the dataset into trend value and test value. The trend value will be input to machine learning model to find patterns or classifications lying behind the data. And then the model that will be used in today is decision tree classifier, since we are looking to predict what kind of machine failure based on numeric data. So after the training, the trained model will be given a test value that is that splitted earlier to predict the outcomes. Of course, we need to compare the real result with the predicted result. Therefore, um, we evaluate the model performance using the accuracy and F1 score module. So lastly, this module evaluated using a confusion matrix, a matrix that visualizes the true and false prediction. And here let's look at our main code today. Okay, so this is our main code. So we have import some pandas and sklearn model, which is the machine learning model. So we can see here requirement text. So as you input the machine learning and the pandas data frame, so basically you can run this code. So the main code consists of loading the data, and then we self-define load data, and then perform the data cleaning. Also, we define data pre-processing with the import of data. And then we select the target variable which we are looking to predict, which is the failure type. And then we drop some unwanted information such as product ID, types, and UID. And then set the data in terms of string. And then set the data column of target variable in Y, and then using the trend test split to split the data set accordingly to trend and test value with default value of test size 0.2. So, and then another defined function is train model to feed this data into a model. And lastly, we make a prediction based on the model and then using the test data. So the result of the prediction will be evaluated using the accuracy score. We also, this is import from sklearn accuracy score, and then they will compare accordingly an F1 score, and lastly the confusion matrix of Y test and prediction. So the print the outcomes. So here's one look of the load data. So this one load the data path, and then the data must end with CSV as in our input predictive maintenance. So this is the data. So load the data. If CSV, we will root the file and read PSV. If not found, we will return to this data file is not found path. Else, it's not fit at the CSV file. And then some handling of the error, which when the data has null value, so this one print a file contain missing value. And then data pre-processing, we will clean handling the missing data, data formatting, clean some product ID, drop column. So here some look. So I will rename the column name, removing the what's called a square bracket to be more accessible, because the column also use a square bracket. So this one quite confusing when you are seeing this. So we remove this and return as data, clean some data to separate product ID, which is there is some low, high, and medium kind of machine. So we separate based on the numeric and alphabet. And then drop column basically drop those random failures that is we are not desired to predict any random failure that is kind of caused by random vibration or noise. So the one is not our desired target today. So we remove this to train the model better to predict what kind of failure that is better to be predicted. And then train model, we use the decision tree classifier and then feed the train data and then return as model, make prediction. If this data need scaling, but by default is no, it will transform the data in using a scaler. If things are all good, we will directly use the predict data and then return as a predicted failure time. Okay, so here we run the code, cd project python project.py. Okay, so basically we can see I have printed the prediction from 0 to 1094. So there's a length of this kind of data. So we can see that this model does very good prediction of 99.6% of accuracy and 99.7 of F1 score. So the confusion matrix basically illustrate corresponding failure type of each failure in diagonal way. So meaning to say, in diagonal way, there is a correct true predicted value for each failure. So those are missed out from the diagonal is the maybe to say is negative or to false positive or false negative that is predicted wrongly. But I would say this model have a good score of accuracy. But what is lacking in this project is we are sticking to the decision tree classifier model. As in reality, we have a lot of model, uh, machine learning model that can be evaluate the similar data to compare which kind of model could be fit this data better. But for this case, I'm choosing the decision tree classifier. If you looking for improvement, you can explore more on the data on the model. And of course, if you are in this domain, meaning to say it's engineering based, you can maybe perform some feature engineering to introduce the features based on the data set. If you're not satisfied with the column here as a raw data, so you can introduce feature engineering. So this for future improvement. I guess this model that I in this project did a very good job to clean and to predict the data up to this accuracy score. So this basically wrap up the project CS50. So thank you for listening, and I hope to see you again. This was CS50. Thank you.